now that we've got some experience solving multi-step equations and those special cases, so let's write the word cases here. And remember, those cases are, I'll just write it right here, no solution and infinitely many solutions. Those are the two special cases that are kind of new for us. So let's go through and let's do these. And the instructions say solve each equation and state the solution the best way possible. So what that means is if there's an answer, let's write the answer. If there's not an answer, then let's say no solution. If there are infinitely many solutions, let's state that as well. So we should know how to solve these. So again, take a look. We always want to simplify before we solve. So let's put these guys together right here. So we have a 4x plus a 2. 2x plus 2, 2x is 4x plus 2, and on the other side it's already 4x plus 2. Well, let's stop and think about this. One side says 4x plus 2, the other side says 4x plus 2, so those two are definitely going to be equal to each other. If we got rid of the 4's, we get 2 equals 2. This is going to be infinitely many solutions, okay? And again, you can kind of tell once you get to this point right here, because those variables are those variable terms are exactly the same. They're the same variable, same coefficient, and then what's left is also exactly the same. So we've got infinitely many right there. Let's take a look at this next one. So again, we're going to distribute through to do some simplifying. So this is going to be negative 2x. Negative 2 times 1 is going to be negative 2. And then we've got negative 2x over here, and then plus 5. And again, at this point, take a look and just read this off. Negative 2x minus 2 equals negative 2x plus 5. The variable part is the same on both sides, but the numbers are different. So we know that that's not going to work. There's no way you can take negative 2x and subtract 2 from it and get exactly the same thing as if you started with negative 2x and added 5 to it. So let's go ahead and get rid of those negative 2's. We basically add 2x to both sides if you wanted to be technical about that. So we get negative 2 equals 5. Those definitely do not equal each other. So what we have here is a situation where we have no solution. Okay? All right, let's take a look at this next one. So we've got 2x plus 9 on this side. If we distribute through, we get 3x minus 3. Now notice the different structure on this one. When we were looking at these two up above, you'll notice that the variable terms were exactly the same. We had a 4x on this side and a 4x on this side, and then the numbers were the same. A negative 2x on this side and a negative 2x on this side, and the numbers were different. So in this case we had infinitely many solutions, and then in this second case we had no solution. Well, let's take a look right here. This is different. We've got a 2x on this side and a 3x on this side. The variable is not going to go away. The variable terms are not exactly the same. So let's solve this like we normally would. I'm going to subtract 2x from both sides. I'm going to move the 3 on this side. That's going to give me a plus 3. So I end up with an x on this side, and I end up with a 12 over here, and that is the answer. So we got a plain old number answer, okay? One of the more typical things that we've been practicing, okay? So if you keep that in mind, then we've got some problems right here that are kind of more thought questions. There's not a ton of work right here. But we need to think about how we can adjust these and make these answers work out and answer the questions here. So once we really understand this, we can tell whether or not we really get it if we can do it backwards. Okay, so in other words, what we're going to do here is we're going to start with the answer and then make an equation that fits that. So as it's written, this equation right here, the one that we did up above, has just one solution, and it says change one or two numbers to write it so the equation will have no solution or infinitely many solutions. Okay, well, the first thing that we have to do in order to have something have no solutions or infinitely many solutions is we've got to make it so the variable term is exactly the same on the both sides. So we could either make this one a 3 to match up with that one, or make this one a 2 to match up with that one. I'm gonna go ahead and change this one right here. So one thing we could do is we could make this a 3x, and that's going to be 3 and then the x minus 1. And then if we want no solution, these numbers these constants need to work out to be different. Well, remember, if you distribute through, this was a negative 3. Let me slide this up so you can see that. Remember, that was a negative 3. Well, if I had that be a 9, if I just left that as a 9, that means the variables would go away. So take a look at this. 3x plus 9 on this side and 3x minus 3 on this side. The variables would go away, and the 9 wouldn't equal negative 3, so that would be no solution. So that would be one way to change it. Okay, there are lots of different ways we could change that so that has no solution. If we wanted this to have infinitely many solutions, then we could do this. Let's stick with the same idea here. Let's do this. let's do, make that a 3x plus 9. And then over on this side, we'd have to have the 3, so we multiply to be an x. But now we want this to turn out to be a positive 9 when we distribute through. So when we distribute through and it's a negative 1, we get a negative 3. Well, we want it to be a positive 9, so we're going to make sure that it's positive. And 3 times what would equal 9? Well, that would be a 3, okay? So if we did that, so I'm going to go ahead and circle this and just show you that this works out the right way. So we get 3x plus 9 on this side, and 3x plus 9 on this side once we distribute through. The two sides would equal each other, so we would have infinitely many solutions, okay? So those are a couple different ways where you could adjust that. If you wanted to, you could change this to a 2, and then you might have to change this 9 or something like that, depending on whether you want infinitely many solutions or no solution. Okay, last one. Let's take a look at this one right here. It says, given the equation 7x plus 5, or sorry, 7.5x plus 67.5 equals 7.5 times x minus 12.2. Without solving, how can you tell this equation might have no solutions or infinitely many solutions? Well, remember, it's got to fit in one of those special case categories if you have exactly the same variable term on both sides. So notice right here, this is 7.5x, and when you distribute through, that would be 7.5x. So what we'd say here is both sides have 7.5x terms. That's the only variable term, is 7.5x on both sides. So we know it's going to have infinitely many solutions, or no solutions. And then it says you can change one number so that it will have exactly one solution. What number should you change? Well, I have no idea what 7.5 times 12.2 is, and it frankly doesn't matter. If we want to make it have one solution, we need to make it so that those are not both 7.5s. So what we'd say here is we would change one of the 7.5x's. So we might do something like this. Let's make this 6.5x plus 67.5 equals 7.5 times x minus 12.2. If you go through and solve that, because this has a 6x and this has a 7.5x, we're going to have an x left and we are going to get one solution. You can go ahead and try it. All right, so your assignment today has more practice, and it also has some problems like this where you need to kind of go backwards and say, well, how could I make this so this has no solutions or infinitely many solutions or one solution? And this should be a good help to you. Good luck.